Hey Chemistry Honor students, this is your Unit 3 podcast number 2. I am going to go through the chapter 17.3, and this kind of finishes up everything that you need to know for the Unit 3 test, okay? I'm going to be covering all of 17.3, so please refer to the book as you look at the podcast, alright? Let's start with something that we already know. This is a phase diagram for water, and as you guys already know, that you guys know what this is called. This is called when solid turns into a liquid. It is what we call melting. And you guys can't see that very well, so I'm going to change that color ink to black. And so this is either called melting, or a scientific term for that is fusion. And going this way, we call it freezing, and this freezing is also a more scientific term for that is called solidification, right? And this change from liquid water to gaseous steam is called evaporation, or otherwise called vaporization. This change from steam going into a liquid is called condensation, and another word for that is condensation. No other word for it, okay? We also talked about sublimation and deposition, but we're not going to go through that for the scope of this unit, okay? So please remember what fusion is, remember what solidification is, remember what vaporization is, and remember what condensation is. So this phase diagram gives you the x-axis of temperature in Celsius and pressure in ATM. However, we're going to assume that the pressure is going to be at 1 ATM, and I'm just going to regraph this information at 1 ATM. So I am going to take my liquid from solid all the way to liquid, all the way to steam, and I am going to graph this with the axis of heat and temperature. And when we do that, we get this diagram right here. And this diagram right here is called the heat curve, and this is a specific heat curve for water. And let me go through the details of this curve in just a little bit. But before we get to the heat curve, let's actually go back to the specific heat table that I gave you guys on the last podcast. And you guys know that liquid water, for 1 gram of it to change by 1 degree, it would need 4.18 joules. For solid water, otherwise called ice, it needs 2.06 joules for every gram of the ice to change its temperature by 1 degree. For gaseous water, otherwise what we call steam, steam needs 1.87 joules per every 1 gram of the steam to change its temperature by 1 degree. I don't know why I drew that. Alright, so as you can see, the liquid water is harder to raise its temperature by, and gaseous steam is the easiest to raise its temperature. So let's take a look at this heat curve for water again. So we know something about water. Actually, before we get into water, let's take a look at the x-axis. The x-axis is heat in calories. So here's small amount of calories and large amount of calories. So as you read this curve from left to right, you are adding heat. So heat added. And as you go from right to left, you are heat is being released. So, and also the y-axis is in degrees Celsius. It is temperature. And you see the 0 degrees Celsius here, which kind of corresponds to the leg B. And here's the 100 degrees Celsius here, which corresponds to the leg D. So, we know something about water. Water, if it is below 0 degrees Celsius, it is a solid. So this leg A represents a solid water, which otherwise we call ice. And between 0 degrees Celsius and 100 degrees Celsius, we know that water is in a liquid form. And we call this just water. And above 100 degrees Celsius, water takes the form of steam. And it is in a gas form, gas phase. But we're interested in what is happening in this leg B and what is happening in this leg D. So let's start from the very beginning of this curve, and let's begin at negative 20 degrees Celsius. So this negative 20 degrees Celsius, if I start at this point right here, and let's call this point A. At point A, ice is a very cold ice. It's a negative 20 degrees Celsius ice. And as I move towards the right on this graph, I'm just adding heat, and that heat is being used to warm up the ice from negative 20 degrees Celsius to 0 degrees Celsius ice. So the small amount of heat that I added is being used to warm up ice from very cold ice to 0 degrees Celsius ice. And this point right here, I'm going to call it point B. And at point B, we have 0 degrees Celsius ice. And as you add more heat to it, the ice now starts becoming a liquid, and that energy that I add is being used to melt the ice into this point C, 0 degrees Celsius water. So you could have 0 degrees Celsius ice or 0 degrees Celsius liquid water, and the energy that I put into the solid ice is being used to break the bonds in between the water molecules and turn that ice into a liquid water. So this is my point C, and from point C to point D, I'm adding heat, and the amount of energy that I add, it is being used to warm up the temperature of the water. And when enough energy is added and it reaches point D, where we have 100 degrees Celsius liquid water, the energy thereafter is being used to warm up that 100 degrees Celsius water and change that into 100 degrees Celsius steam. And at this point, as the liquid water is turning into steam, you can see that all the energy is being used to change the liquid water into a gaseous water, and no temperature change is happening. And that is why water, as long as you have when you see water and steam, you stay at 100 degrees Celsius water. Whenever you have boiling water, it is at 100 degrees Celsius at 1 atm. So in this leg D, we see both solid and liquid. In leg A, we only see solid. In leg B, we see both solid and liquid. In leg C, we see liquid only. On leg D, we see not solid and liquid, liquid and gas. And once all of the liquid has turned into a gas, the heat then is used to warm up the steam to hotter steam. And at this phase, you only see the gas.